Okay, we're looking at this and we're thinking backwards to ourselves. We're given the derivative function and we want to figure out what the original function is. And so first of all, let's not ignore that 2t for a second. If we were thinking about what gives us the derivative, would give us back sine. Well, I know that the derivative of negative cosine gives me back positive cosine. And so f of t, I will have a negative cosine, but remember when we take the derivative, we have that inner piece, it keeps the same, which is going to be the 2t. And we would take the derivative of the inside, and the derivative of our inside would just be 2. So we need something in front that would give us a positive 1 here. So I'm thinking to myself, what can I multiply 2 by to get back 1? Well, that would be 1/2. And so I'm going to have this as a negative 1/2 in front. And we'll test it in a second. So plus, so we're trying to think backwards again. What can I take the derivative of to give me cosine? Well, I know that the derivative of sine is cosine. And so I have sine of the inside t over 4. When I take the derivative, though, of sine of t over 4, that would give me cosine of t over 4, but it's also multiplying by the derivative of the inside. And the derivative of the inside is 1/4. So I need something to cancel out with that 1/4 to, again, give me a 1 here. And 4 times 1/4 is 1. So I would have a 4 out here. The thing is that, remember when we take the derivative of a constant, we always get back 0. And so we could have any constant added on here, and we'll call it c. And that would give us, if we took the derivative, back this. And so let's just check it and make sure we got it right. And so taking the derivative of negative cosine of 2t, negative 1/2 of cosine of 2t, we leave our negative 1/2 alone, times derivative of cosine is negative sine of the inside 2t, times the derivative of the inside 2t, which is 2. Plus, so let's keep the 4 out here. And now let's take the derivative of sine of t over 4. So the derivative of sine is cosine of the inside t over 4 times the derivative of the inside. We'll think of that as 1/4 times t. So the derivative of t is just 1 times that 1/4 in front, so 1/4. Plus, derivative of any constant is always 0. So cleaning this up a little bit, I have a negative and a negative, so that's positive. I have a 2 in my denominator, a 2 in my numerator. And so I'm left with positive sine of 2t plus this 4 here in my numerator, 4 in my denominator cancels, leaving me with cosine of t over 4, which is what I originally was given. And that's what I wanted to show, is that's what I would get back. So we found out what the original function was given the derivative function. So we're always really, when we're going backwards, we're always going to have to add in this constant c in here, unless we're given bounds. And sometimes they give us enough information to figure out what c is. For instance, they might say f of 0 is equal to 1. So they might give us this derivative function, say find f of t, and we know when f of 0 is 1. And if that's the case, then we would go in here and we would plug in 0 wherever we saw a t, set our function equal to 1, and then just solve for c. C would be the only variable left in there. So there are some problems, I believe, that look like that, but this one didn't have that. Okay, so this next example says, explain why if a runner completes a 6.2 mile race in 38 minutes, then he must have been running exactly 9 miles per hour at least twice in the race. Assume T runner speed at the finish line is 0. Okay. So select the correct choice below, and if necessary, fill in the answer box to complete. So the average speed is blank miles per hour by MVT. The speed was exactly blank miles per hour at least twice by the intermediate value theorem. The speed between blank and blank miles per hour was constant. Therefore, the speed was 9 miles per hour to reach at least twice that race. Oops. Okay, so we were looking at the fact that distance equals rate times time. We first converted our 38 minutes into 19/30 hours. We plugged in our information that the distance was 6.2 miles equals our rate times the time, 19/30 hours. And we got that our rate that we were running, and this is just approximate, this is the average rate, is 9.8 miles per hour. Well, if that's the average rate, then somehow they had to increase, right? When you start the race, you're not running at all. You're going to start running and you're going to increase your speed, right? And so here we have to get up to some 9.8 miles per hour. We're going to need some over this 9.8 to average out this piece where they were running slower. And then when we stop the race, right, we're going to have to slow down. And so we're going to have to come back down to the stop position. And so we know that there's going to have to be at least 2 places in here where they're running at 9.8 miles per hour. Okay, so let's figure out where we need to put for A, B, or C.